All right, we are going to look at 3 examples of solving systems of equations using the solving by graphing method. So our first system is the one shown here. We have 2 equations, right? We have our top one and our bottom one that together make our system. So step 1 says, look at the equations. Are they both in y equals mx plus b form? So this is called slope-intercept form. So looking at it, the top equation is in a y equals a number times x and a constant. And the bottom equation is also in y equals, there's an invisible number, 1x plus 2. So that also works. These are both in mx plus b form. A really good tip is if you just have a plain old y equals, you are good to go. So we are going to go down the yes path because these are indeed both in slope-intercept form. And so it says, okay, go ahead and actually graph both of these equations. Before we do that though, I am going to identify some key features of each equation. So equation 1 is this top one that I'm going to do in blue. It has a slope of 1/4. So that means we're going to rise up 1 as we run forwards 4. And then a b value, so y-intercept of -1. So I'm going to go ahead and graph that by putting a beginning point at -1. And then I'm going to get additional points by doing the slope. So up 1 over 4. And then you can reverse it. So instead of up and over, we can go down and back. And then just do your very best to connect it in a straight line. And I've got the power of the iPad to make it look a little sharper and I can straighten things out. Ideally, you would use a ruler to make this really precise. And we do need to be shooting for precision here so we can see exactly where these lines will intersect. All right, so that was my first equation. Now going to the second one, which I'm going to do in this reddish color. The slope, it is there, it's just a little bit invisible, so we have a 1x, and then I always like to write slope as a fraction, so 1 over 1, and our beginning value is 2. So starting off, we are going to start 2 up on that y-axis, and then up 1 over 1, up 1 over 1, and you can just keep doing that. In both directions. So I put a lot of points down. You do not need this many, but get enough. That way you can get a really precise line. And again, I'm using the power of the iPad. You would use a ruler to go ahead and do this. All right. So we have graphed both of our 2 given equations, and we are now moving on to step 3, which is locate the point of intersection. So looking at what we have going on, we have a point of intersection right here. And remember, it's x and then y. So on the x-axis, we had to go back 1, 2, 3, 4 spaces to get to that intersection point, and then down 2. So our point of intersection is going to be -4, -2, right? Because we went backwards 4, down 2. It's really important to remember that coordinate points go x and then y, right? Coordinate points go in ABC order. X always goes before y when graphing. So just make sure order matters. It would not be valid to write -2, -4. All right, so now that we've done our work to actually graph these, sometimes mistakes happen. So it's really good form to always check your solution. And that's what step 4 is. It says, check the solution by substituting the x and y values from this point, so -4 for x and -2 for y, back into both of the original equations. So I'm going to quickly copy down the original equation. So we have y equals 1/4 x minus 1. And then the other equation was y equals x plus 2. So just a reminder, a solution is a value, or in this case, an ordered pair of values that makes an equation true. So when we substitute in -4 for x and -2 for y, we are looking for it to make a true statement. So we are going to start substituting and just make sure that what we get is a true statement in the end. So starting off, instead of y equals, our y value from the point of intersection is -2. And then I am going to put a question mark because I'm not sure if this is correct. And so it equals 1/4 times x, but instead of x, we are going to substitute in the x from our solution, which we believe is -4, and then subtract 1. So at this point, you have a few ways that you can do this. You can either order of operations it. If your teacher is okay with it, you can type it into your calculator, but we need to figure out what each side equals. So the first side is just -2, so easy peasy. Now over here, 1/4 of -4 would just be -1. Take away 1 more equals -2. And -2 does equal -2, so that side checks out. That's perfect. All right, and we're going to do the same thing. We need to make sure that this works out for both of our equations. If you have a coordinate point that works for one but not both equations, it's not actually a solution. And that would tell you that somewhere you goofed along the way and you would need to go back, check your work, and figure out where the error happened. All right, so proceeding through our check, I'm substituting in -2 for y, and then -4 for x, and then our task is to see, does it actually check out? Does one side equal the other side and make a true statement? So -2 is still -2, nothing is going to change that. And then over here we have -4 plus +2, which is -2. So that's perfect. Each side equals each other, and that tells us with confidence that our solution is -4 for x and -2 for y. And we can see that as this point of intersection where the two lines crossed each other. All right, going to a second example. Again, we are going to do 3 total examples. This time we have y equals 3x minus 4, and then our second equation is 3x take away 2y equals 2. So step 1 says, look at our equations. Are they both in y equals mx plus b form, also known as slope-intercept form? No. The top equation is in y equals form, but the second one certainly is not. So we are going down the no pathway. And it says, okay, well, rewrite the equations so that they are in y equals mx plus b form, which essentially means solve for y. So the top equation is already in y equals form. It's good to go. We only need to do this for the second one. So we have 3x take away 2y equals 2. And again, our goal is to isolate this y so it can be in y equals form. So go ahead and subtract 3x from both sides. So this would make a 0 pair, that's gone. Be very careful that you remember to drop down the negative with your 2y. And so we have the -3x we just subtracted over, along with the +2 that was already there. All right, the next thing that we need to do is get rid of this -2 because we don't want it to be along with the y anymore. So we are going to divide everything by -2. And that will leave us with +1y. And then a negative divided by a negative will give us a positive. And then -1. All right, so this is our new and improved second equation. All right, so we took a little detour to do some rearranging, but now we are ready to go to step 2, which is graph both of these equations. So from the original, the one that had no issues up top, this one, the y equals 3x minus 4, our slope was 3, which is 3 over 1 as a fraction. And then our b value is -4. So I'm going to go ahead and graph that, starting 4 down on the y-axis and then going up 3, forward 1. And I'm just going to keep doing that till I run out of space and then reverse the pattern. So instead of going up and forward, I'm going to go down and back. All right, and then connect the dots with a straight line. And again, you are trying to be very precise. That way we can see where these lines will intersect. Again, I get the power of the iPad, you get the power of a ruler or the side of your binder, an index card, a book. Find something, but again, precision. All right. Now for equation 2, we are going to look at what we got over here from rewriting it. Right? We only want to look at the slope-intercept form since it makes it really nice and easy to graph it. So from this new and improved version of equation 2, our slope, or the m value, is 3/2, and it's already a fraction, which is great, so we can see that rise over run pattern. And our y-intercept is -1. So starting at -1 on the y-axis, we are going to rise 3, run forward 2. And then I ran out of space, so now I'm going to reverse the pattern. So instead of rising 3, running forward 2, I'm going to fall 3 and go backwards 2. All right, once again, use something to get a very straight edge. All right, and step 2, graph both of the equations, is completed. So we are now going on to step 3, which is locate that point of intersection. And zooming in, it is right here. So looks like we go forwards 2 and then up 2. So our coordinate location as an ordered pair would be 2, 2. And remember, it's the x, which was how far we went side to side, and then the y, which is how much we went vertically. So just to confirm this, because we did do some work and mistakes can easily be made along the way, we are going to check our solution by substituting the x and y values from this point of intersection back into the original equations. And it's really important that we use these original equations and maybe not this new and improved one, just because maybe we made a mistake when we did some rearranging to get it into that slope-intercept form. So it's always good practice to go back to this original, what was printed on your paper, because we know nothing was messed up at that point, right? No mistakes were made. So copying down those original equations, the first one is y equals 3x minus 4. And then the second equation is 3x take away 2y equals 2. All right, so now we are going to substitute, and this one's kind of cute because both x and y are 2. So we're going to substitute these values in and then make sure that each equation produces a true statement. Because again, a solution is a value, or in this case, an ordered pair of values that makes an equation true. So starting off on equation 1, we're checking, does 2 really equal 3 times 2 minus 4? So if we do this, 3 times 2 is 6, take away 4, that's 2. So that one checks out. And then on the other side, does 3 times 2 take away 2 times 2 actually equal 2? All right, so let's think about it. 3 times 2, that's 6. 2 times 2 is 4. 6 take away 4, that's 2. So that checks out, and we can say with confidence that our perfect answer is 2, 2, since that is what we found as this point of intersection over here. All right, final practice problem. So this time our system consists of 2x take away y equals 6 and y equals negative 2x plus 2. And our first question is the same, which is look at our equations. Are they both in y equals mx plus b form? And this is another no. The bottom equation is, this one's in y equals form, but the top one is not. So we have to go down the no path and do a little bit of background correcting work. So the one that's already good to go this time is the bottom, and it's the top that needs to be rearranged. So again, when we are going into this slope-intercept form, or y equals mx plus b form, you need to solve for y. Right, so you are isolating the y variable. So go ahead and write that equation down. 2x take away y equals 6. And we're going to start getting rid of terms to isolate the y. So the first thing to get rid of is the 2x. So we'll do that through subtraction. This leaves us with negative y equals the negative 2x we just subtracted plus the 6 that was already there. And then be cautious of thinking you are done. There is no negative y equals mx plus b option. You need to get rid of this negative, and it's really helpful to remember that this means negative 1, which is being multiplied by the y. So to get rid of it, we are going to take this invisible negative 1 and divide each term by it. And this will end up giving us a positive y, which is what we're looking for, equals 2x minus 6. And this is our new and improved equation number 1. So looking at what we have, so going to step 2, equation 1 now has a slope of 2, which is 2 over 1. And we have a y-intercept of negative 6. And then looking at equation 2, it has a slope of negative 2, also known as negative 2 over 1. That way it can have a rise over run fraction. And our b value is positive 2. So go ahead and plot these points. The first one, we're starting 6 down on the y-axis. And then our slope says to rise 2 as we run forward 1. Again, once you run out of space, reverse the pattern. And then with a focus on precision, connect the dots. I will be using the power of the iPad to make this really nice. You will go back and make sure that you are using a ruler or something else to make sure that this is really straight. All right. And then going to the next line, we are going to start 2 up on the y-axis. And then this time our slope is negative, so we are going to fall down 2, but still run forward, right? By default, if our slope is positive, we go up and forward. If our slope is negative, we will go down and forward. So down 2, forward 1. All right, connect those points very precisely. All right, and now you should be ready for step 3, which is locate that point of intersection. All right, so zooming in, this time our intersection is 2, negative 2, because starting at the origin, you have to go forward 2 and then down 2. So again, 2 and then negative 2. This is our x and our y value. And doing our check, remember we always go back to the original 2 equations, not using one of our rearranged. So we are first going to start off with 2x take away y equals 6. And then our other original equation was y equals negative 2x plus 2. All right, so we are checking 2 for x and negative 2 for y. So everywhere that you see an x, you are going to substitute it with a positive 2. And everywhere you see a y, you are going to substitute it with a negative 2. And then we're just checking, does it actually produce true equations? So this one's a little trickier. So 2 times 2 is 4. And then we're minusing a negative. So remember that this would become a plus here. So we have 4 plus 2, which is 6. So woo! So far so good. And then checking the second equation. All right, so checking this one, we have -2 equals, and then over here we have -4, and then +2, so that indeed is -2. And so again, -2 equals -2, so that is a perfect true statement. Over here, 6 does in fact equal 6, another true statement. And our ordered pair, our coordinate point, makes both equations in our system true, which means that is the solution. So with confidence, we know that 2, -2, again, which corresponds to this point of our intersection, is the correct final answer. All right, so that was 3 examples of solving systems of equations by graphing.